Dr. Josué Domínguez Guerrero graduated in electronic engineering from the Instituto Tecnológico de Durango in 2009. He completed both his master's and doctorate in digital system sciences at the Center for Research and Development of Digital Technology, part of the Instituto Politécnico Nacional. His academic focus lies in multi-objective optimization using bio-inspired algorithms. Since 2017, he has been a full-time professor at the Universidad Autónoma de Ciudad Juárez, where he teaches in the Computer Systems Engineering program. He has supervised a wide range of thesis projects on topics such as combinatorial optimization, convolutional neural networks, single-board computer systems, and object recognition in images, among others. I hand over the word to Josué Guerrero.
Okay, this work, automatic review of handwritten flowchart using convolutional neural network, is of my degree student, Alexa. So, introduction. Okay, importance of flowchart in education. This work is, I'm teaching programming in C and fundamentals of programming. So flowcharts are important to help the students organize programming concept and visual before writing code. This is the importance of flowcharts. Also, creating flowchart by hand boosts cognitive skills and deeper understanding of problem-solving process. So this problem, we try to do an automatic tool for the text handwritten flowchart component to improve the learning outcomes. Okay, the objective of the project objective was use YOLO P9 to model to detect symbols in handwritten flowchart. This tool provides feedback on flowchart structures and verify elements like start, end nodes, and connectors. Okay. For this work, we made an previous investigation. Some investigation says that flowcharts improve students' comprehension of algorithmic concepts by visualizing representing problem-solving steps. This is important for the students before they start programming. The flowchart also helps to identify common errors before they start to code. Okay. Another words for other authors use the CNN to advance of recognition patterns in handwritten diagrams over time. And other authors that are use the faster RCNN and RCNN to detect the symbols on handwriting. Another method is OSHDR and IFDR detect. Okay, our approach some works use the flowcharts to generate code automatically. For example, flow to code. This convert the flowchart to code, but this is not our approach. Another, the first one is directly from handwriter. The second is for some made in some program like Visio or another. In this one, compilers direct to the PHP errors, and there are others to have. Okay. In our approach, that we use the standard ISO. Some frequent problem with the the student is the symbols are not in the standard. For example, PSINT or DFD use some symbols to input data that is not with some arrows in the right. And so our project use the standard, see, the standard for the flowchart. Okay. For this, we use a convolutional neural network that previously are explained in other talks of this work. Okay. Specifically, we are the YOLO algorithm B9. And the YOLO is use one convolutional neural network to analyze the wall image in single pass, providing efficiency. Okay, our proposed work. First, we need to collect the data. For this one, we use another words and handwritten flowcharts for my students. So we collect the data and we use the template in RoboFlow. After that, we select only 9 symbols for the handwritten. No all the symbols in the standard. Okay. After that, we automatically label the images in RoboFlow, and manually we ensure that they are correct. After that, we use data augmentation techniques to generate this image. Okay. This is the class that we use: arrow line down, arrow line left, arrow line right, arrow line up, the symbol of decision, the symbol of pointer, print, process, scan, and start and end. Okay, this is an example of in RoboFlow, a start symbol, process, the arrows, input, output, and end. Okay. After that, we prepare the data. 70% of the math was for training, 20 for validation, and 10 for testing, of a total of 177 images. Okay. After that, we are the following transformation where the assign of the image for preparation. Apply auto orientation, assign the image size 640, and apply a grayscale, adjust the color contrast, and create a measuring 2 columns by 2 rows. Okay. After that, we train the model. The model that we used was YOLO V9E. This work is started 2 years ago, and with YOLO V7, and then YOLO V9, and now it's YOLO V11 thing, and it's always is fair. Okay, for this one, we training in Google Colab using T4 GPU. After that, use for 12 epochs to optimize performance, and after that, we validate our training. After that, we apply the model inference application to perform inference and detect symbols. And the result, okay, here's a plot of the loss, lower box, and DFL loss. This is the evaluation of precision metrics. We can see the precision, the recall, the MA50 here, and the result on real diagrams. See, here we can see the begin, the process, the arrows. Some arrows were not recognizing correctly, indicate areas where the system need improvement. Probably here we can use some classical techniques for image processing like dilation or erode, I don't know. But the other symbols was classification correctly, only the arrows we have problem. For future work, we need to expanding the data set to improve model accuracy and robustness. Arrows in diagrams provide difficulty to are required, indicate areas for improvement. And the tool shows significant promise for educational application in learning diagram interpretation. And also, we use quantum algorithm to train the algorithm in this one.